Since 2018, information systems research has been flooded by a single recurring concept: sovereignty. As the global volume of data generation accelerated, so did the academic literature attempting to define how to control it. Out of this academic surge, three distinct terms dominated the discourse: data sovereignty, digital sovereignty, and technological sovereignty. But a critical error has emerged in the industry. Systems architects, developers, and researchers are frequently treating these three terms as exact synonyms. Misidentifying these terms leads to architectures that fail to meet specific legal mandates. If a designer attempts to satisfy a national resource strategy using only a localized data security protocol, the resulting system cannot bridge the gap between technical execution and regulatory requirements. Building robust data ecosystems requires mathematical precision. When operational definitions are blurred, the resulting software architecture lacks the structural foundation to remain compliant. To untangle this conceptual overlap, a 2023 systematic literature review by Helmier and von Scherenberg isolated exactly how these terms function across different domains. This flowchart outlines their methodology. They started with a massive pool of global literature across major databases and filtered the duplicates and irrelevant texts, reducing the final dataset down to 81 relevant information systems papers. Their analysis reveals that these terms describe separate phenomena. They represent three distinct operational domains, separated by scale, the actors involved, and their ultimate objectives. These domains form a three-tiered sovereignty stack. It descends from the macro geopolitical level of technological, through the societal layer of digital, to the micro-architectural level of data. Implementing the code for a sovereign data transfer requires an engineer to account for the macro-political layers sitting directly above the architecture. Technological sovereignty is the very top layer of the stack. It operates exclusively at the level of nation-states and international federations. This domain does not imply total independence. Autarky is a practical impossibility in a world of highly integrated global supply chains. Instead, technological sovereignty measures the capability of a state to source, develop, and apply critical technologies without suffering from one-sided structural dependencies on foreign economic areas. This layer is rooted in physical reality. The digital realm depends on hardware, which requires the extraction of raw materials, resources that are often concentrated in specific geographic regions outside of a state's borders. States mitigate these dependencies by leveraging strategic relationships, enforcing legal protectionism, and negotiating international treaties. This geopolitical posturing dictates where states can legally deploy physical infrastructure, like the undersea cables that route data across national borders. Technological sovereignty defines the geopolitical boundaries. No digital architecture can operate outside the limits established by physical hardware and national treaties. Moving one layer down the stack, we reach digital sovereignty. This governs national economies and societal infrastructure. This layer focuses on the ability of a society to shape its digital transformation in a self-determined way. It requires broad digital expertise across the population and sovereign control over IT infrastructure. Regional political bodies establish these boundaries by drafting the legal and economic regulations that dictate how digital systems operate within their society. These policies generate a specific engineering mandate: interoperability. The goal is to prevent corporate vendor lock-in, ensuring that users can select and use digital assets without being bound to a specific technology. Digital sovereignty acts as a legal perimeter. It forces isolated organizational networks into standardized communication protocols when they connect across a society. This layer translates macro geopolitical boundaries into the legal and infrastructural constraints that businesses and individuals must obey. Finally, we reach the bedrock layer: data sovereignty. This is the precise domain of information systems researchers and software engineers. This layer operates at the micro level, focusing on individuals and single organizations protecting specific data assets. The core metric here is self-determination, the capability of a data provider to maintain granular access control over their data, even after sharing it with a consumer. Historically, security relied on written contracts. In automated, high-speed digital transactions, those paper agreements are too fragile to protect data assets effectively. The solution is to replace paper contracts with codified, enforceable technical solutions, such as the International Data Spaces, or IDS, connector. These algorithmic architectures ensure that usage policies are mathematically enforced upon distribution. Identity validation and usage control monitor and block unauthorized access requests in real time. Data sovereignty provides the technical execution that satisfies the higher-level legal and infrastructural constraints. Interrogating the data behind these frameworks reveals who is actually defining the rules of the stack. This map shows the geographic distribution of foundational information systems literature regarding data sovereignty. There is a massive disparity, with 72. Contrast that with minimal input from North America at 15%, Asia at 11%, and 1% representing Africa and Australia. This geographic bias affects architectural design. Large-scale data ecosystem frameworks like Gaia-X are optimized for European legislative environments, specifically the GDPR and the Data Act. These frameworks are not universal engineering constants. Deploying them outside of Europe requires architects to reverse engineer the specific regional policies the code was built to satisfy. The sovereignty stack establishes a functional hierarchy for system design. Using these three terms interchangeably ignores the structural boundaries of the digital economy. Technological sovereignty is geopolitical resource control. Digital sovereignty is infrastructural interoperability. Data sovereignty is algorithmic asset control. The system operates on a principle of top-down constraint. International treaties limit network hardware, and that hardware limits digital routing laws. The constraint cascades downwards to the code. Architecture requires bottom-up compliance. Localized data space code must satisfy the interoperability and security mandates passed down from above to function legally. For a systems architect, simply writing secure code is only 1/3 of the overall equation in modern data ecosystems. Designing resilient systems requires information systems professionals to look beyond their development environments. They must account for the geopolitical and legal frameworks that establish their ultimate engineering constraints.